Hello friends, welcome to the channel. Today the problem is maximum sum without adjacents. The problem statement is given an array of size n containing positive integers, find the maximum sum of a subsequence such that no two numbers in the sequence should be adjacent in the array. So we have to find the maximum sum of all this. We have to find all the subsequences, then find out the maximum sum, and that maximum sum should not contain any elements which are adjacent to each other. So to understand it more clearly, let's try to break it into smaller parts and then understand. So suppose we have only one element in an array. So the possible answer is only one, that is 5. Now suppose we have two elements in the array, 5 and 7. Now the answer could be either 5 or 7. We have to take the maximum, so the answer would be 7. Now we have three elements in the array. Now the possible answers could be either element 1 or element 2 or element 3 or sum of element 1 and 3, that is 5. 3 plus 2, that is 5. So here the maximum is 8, so we'll take 8. 8 would be our answer. Now suppose we have 4 elements. So to calculate the answer of this, we first have to find out the maximum among these two. Then take the third element, find out the maximum sum possible in these three. Then take the fourth element and find out the maximum sum possible in these four elements, including the adjacent elements. This is how. Let's let's solve it to understand. So to solve this, we'll take one variable v1, another variable as local sum, another variable as maximum sum. Okay. So here v1, let's take v1 as the first term. Now local sum, then we have to take two elements and take the maximum as local sum. So 6 would be the local sum, or 6 plus 0. Initially it will be 0, then 6 plus 0. 6 would be the maximum of these two. The maximum sum would be, we'll take third element and we'll start a loop by considering the upcoming elements. More elements will come, we'll handle them. So when 3 comes, so when we would do 3 plus first element, that is 4. 3 plus first element 4, that would be 7. Now compare it with the local sum, whichever is local sum. 7 is maximum. 3 plus sum versus local sum, and the winner is 7. So now local sum, value of local sum will become the next term, and local sum will get 7. Now we'll take up the next element 1. We'll add it to the first term, 1 plus even, that is 6, and compare it to local sum and compare it with that. Both are equal, hence 7 will be the answer. So I hope the things are getting clear by this time. If not, do ask me in the comments, I'll explain it again with more simpler terms. So to solve this, what we need to do is first eliminate few cases when we have limited terms. If n is equals to 0, then return 0. if n equals to 1 and term is equals to arr 0. So first term will store here, and if only one term is there, then it will return it. Now, and max. Local max is equals to dot max term comma arr 0. No, it should be arr 1. Both are same. Go. So if we have only two elements, we'll return the maximum of these two. Now, if there are more than two terms, then we'll start a loop and I equals to I is less than n, I plus plus. We have handled two elements, now we'll handle more upcoming elements. So to handle more elements, we need to take a variable and sum equals to 0. Let's call it maximum sum or max sum. So max sum equals to math dot max maximum of first term plus upcoming term versus local max. This is what we are doing. We are taking the elements which is coming here one by one, adding it to the comparing. In this case, suppose we take this array. Let's write it here. 5, 5, 10, 100, 10, 5. So let's make it 6 and make this one 7. So we'll take the first term is 5, we'll add it to the next term, that is 10 here. 2, 0, 1, 2, second element. The element at index 2 is 10. So we'll add 10 plus 5, that is 15 here, and compare it with the local max. Local max was 6. So 6 is compared with 15. So max sum will store that. Now, once we have done that, we need to update our terms. So term becomes local max. Local max. This one. Term becomes local max. Local max equals to maximum. We're preparing for the next iteration. Now for the next iteration, local term is here. Now term is local term was 6, it is transferred to term, so term became 6. The new element which came was 100, so it became 100 plus 6. So now you see this process will be repeated as new terms will come, they will be handled and appropriately the maximum sum would be calculated. So maximum sum will be stored in our maximum variable. So here the answer is correct. Let's see if it is submitted or not. It is accepted. If you want There's also a recursive solution to this problem. If you want that, ask me in the comment. I'll provide the video of that also. So here it is. Very simple and elegant solution. Thank you for watching. Do consider subscribing. See you again.